Okay, so today we are going to be calculating the gradient at a point on a curve, right? So in order to do this calculation, you would have to be able to do limits. I do recommend you watching our video on limits first before going forward. Okay, so let's continue. So we know our gradient equation is y2 minus y1 over x2 minus x1, right? So that would be yq minus yp divided by xq minus xp, right? So we can see that these are these 2 points, right, on a particular curve. And let's say this is a point A on the graph and this is A plus h, right? That's the x point for q, and let's say that the y point for p is f of a and the q point is the yq point is f of a plus h, right, plus that extra distance, right? So then we can rewrite this equation as this, right, to try and solve the gradient of the curve. And as we simplify, these two a's cancel, we're left with this equation, right? So to calculate the gradient on a curve using limits, you can use this equation, right? So let's try and apply it and then let's see what happens. So as we see, the reason why we're using limits, because we're trying to find out the gradient of this particular point, right? So we can see as this q point gets closer and closer to p, right, as h becomes 0, because we said that the gradient is, right, so as this point gets closer and closer to p, right, on that curve, right, we can see it's tending towards this gradient equation, right? So we can see the h is becoming 0 in that equation, right? So if h is 0, then we just have f of a, right? If that h becomes 0, then it just becomes a, right? So as this h distance becomes closer to 0, we can calculate what the gradient is, right, at that particular point to the tangent of the curve.